Okay, alright. Welcome again in another tutorial. In this tutorial, we shall continue with the derivative of exponential functions. Before we continue with this tutorial, I'd like to recommend you to watch a tutorial called Derivative of Exponential Functions, which was a tutorial made just before this tutorial. So in this tutorial, we have an exponential function y equals to a power x. Okay, this tutorial is called Derivative of Exponential Functions 2. Okay, derivative of exponential functions, ile tutorial nyingine tumederive y equals to e power x. Tafadhali angalia ile, itasaidia kuelewa zaidi na hii hapa. So hapa we have a function y equals to a power x, where a is a constant and a is greater than 0. Sasa, as usual, we want to know the derivative now of this function. Okay, sasa ile e power x nilifanya first principle. Hii hapa nikifanya first principle, kuna mahali nafika na kwama. So nitafanya first principle afu nitakuonyesha ninapokama. Ndio maana nasema ni muhimu uangalie ile tutorial iliyopita ili ufananishe. So by first principle najua dy dx is just the limiting value as delta x approaches 0 of y plus delta y minus y over what? Over delta x. Alright? Yeah. So y plus delta y is just going to be equal to a. Kwa sababu y imekuwa incremented na x na yenyewe bila shaka imekuwa incremented hiyo. So this is just going to be equal to the limiting value as delta x approaches 0. So we have a x plus delta x minus a power x over delta x. So my dy now, dx, is just going to be equal to the limiting value as delta x approaches 0. So we're going to have a power x, we're going to have a power delta x, a power x times a power delta x minus a power x over delta x. Kwa hiyo hii hapa ni sawa tu na hii hapa. So a power x hapa na hapa ni common, naweza nikaifactor out. So I'm going to have now dy dx is just going to be equal to the limiting value as delta x approaches 0. We're going to have a power x, huko ndani tutabaki na a power delta x minus 1 over delta x. Sasa kwenye ile tutorial iliyopita tulivyo derive hii by first principle tulifika kama hapa. Then tukasema as delta x approaches 0, e power delta x minus 1 over delta x, it just approach 1. So this was true, but for this one now, kusema kwamba he over he approach 1 is not true. It is not the case. Okay, so this is not the case. So this is not the case. This is not true. And why now? Remember, e was a constant here hapa. Okay, lakini a sasa, we don't know the value of a, okay? We just know a is a constant and is greater than 0. So it could be any constant. It could be 10, it could be 100, it could be 400, it could be 1 million, and etc. So, when a is equal to e, it will be true. But for a is equal to some other value, it will not be true. Therefore, siwezi kuendelea tena na first principle kwa namna hii. Manake, nitafuta utaratibu mwingine sasa wa kupata derivative ya a power x. Au kama ni first principle, basi nifanye kwa njia nyingine. So that's your homework. Kwa first principle, siwezi kuendelea kwa utaratibu huu. Sasa nafanyaje sasa ili nipate dy dx for y equals to a power x. Okay, nafanya nini ili nipate hiyo? So, ili nipate dy dx for y equals to a power x, nitakachokifanya sasa, nita apply natural logarithm both side, okay? Kwa makini na hii njia. Okay, apply natural logarithm huku, ln y itakuwa sasa na x, ln a. So nikiderive huyu ln y, itabaki na 1 over y times dy. Hapa differentiate with respect to y. Nikija upande wa huku, differentiate now with respect to a, x, a is a constant. So, ln a is a constant, nitatoa nje. When I differentiate x with respect to x, I'll get 1. Okay, so I'm going to times this with dx. Kama huku nilivyo times na dy, huku nime times na dx, okay? So, let me just repeat this, okay? Nime differentiate ln y with respect to y. Sawa, nimepata 1 over y. Kwa sababu nime differentiate with respect to y, lazima niongeze hii dy. Nika differentiate x ln a with respect to x, nikapata ln a. Kwa sababu nime differentiate with respect to x, lazima niongeze hii dx. Okay, sasa nitagawanya kwa dx both side because I am looking for dy dx. Kwa hiyo itakuwa ni 1 over y dy dx is equal to what? Is equal to ln a. So now nitapata hivi 1 over y dy dx equals to ln a. So I will times now by y here and then I will times by y here. So this and this go. So now my dy dx is just going to be equal to y ln a, okay? But I don't want to have a y here. So I know y equals to a per x because x is the independent variable. I just want to have values of x. So my dy dx is just going to be equal to a per x ln a. And now this is the derivative of a per x, okay? Kwamba ni sasa na a per x ln a. Kwa hiyo hivi ndivyo unapopata derivative ya hiyo. Kwa hiyo sasa kama una swali labda say y is equal to 10 per x, it means dy dx is just equal to 10 per x ln 10. Sawa, yeah. So let's try and solve another much more complicated example. I call this example 1. It says find dy dx if y is equal to 10 power negative x. Now we have a negative. So what am I going to do? I'm going to use chain rule. I'm going to let w equals to negative x. So this means y is just going to be equal to 10 power w. So now dy dx is just going to be equal to dy dw times now dw dx. Alright, so now my y is just equal to 10 power w. So if I derive this one now in terms of w, I'm just going to get what? 10 power w ln 10. Okay, kumbuka nimetoka kuiderive sasa hivi. Lakini nina w is equal to negative x. So nikiderive huyu nitapata nini? Toa negative 1 nje, derive x napata 1. 1 times negative 1 nabaki negative 1. So now my dy dx is just going to be equal to dy dw is 10 power w ln 10 times negative 1. So now my dy dx is just going to be equal to 10 power w, okay, negative 10 power w ln 10, hivyo. So I want to simplify that further, naweza nikaandika as 10 power w times negative ln 10, okay? So now, hii hapa, nataka tu ni simplify zaidi, dy dx is just going to be equal to 10 power w, it's going to be equal to negative ln 10, okay? Hii sasa na 10, remember w ni negative x, okay? So itakuwa ni ln 10 power negative 1. What is 10 power negative 1? 10 power negative 1 is just equal to 0.1. So now my dy dx will just be equal to 10 power negative x ln 0.1. So this one is dy dx when y is equal to 10 power negative x. Now let's see another example. I will call this now example 2. I will call this example 2. So we have y is just equal to 4 power ln 4x, okay? We want to find dy dx here. It says find dy dx, okay? If that one. Now, so I have y is equal to 4 ln 4x. So I'm going to use chain rule. I'm just going to let w is equal to ln 4x. So it means my y is just equal to 4 power w. Dy dx is just going to be equal to dy dw times dw dx. Okay, so now w is equal to ln 4x. Okay, so I mean the w dx now itakuwa ni ngapi? This is what I'm looking for. I'm afraid I have to use chain rule again. So I'm going to let u is equal to 4x. So my w is just going to be equal to ln u. Okay, so now to get the w dx, I'll have to use the chain rule. It's just going to be the w du times du dx. So from this one, w equals to ln u, I can get my dw du, which is just going to be equal to 1 over u. And now from that one, u equals to 4x. U equals to 4x. I'm going to get my du dx is going to be equal to what? To 4. So now nimesema dw dx is equal to dw du times du dx. So dw du nimesema ni 1 over u, wakati du dx ni 4. But what is u? U is 4x. U is 4x, so this is just going to be equal, so my dw dx is just going to be equal to 1 over 4x times 4. So the 4 and 4 goes. So dw now dx is just going to be equal to 1 over what? Over x. So this is what? This is my dw dx. Now, after having my dw dx now, I want to find my dy dw dx. Okay, so dy dx is equal to dy dw times dw dx. So my dy dw is just 4 per w ln 4, and this one now is just equal to 1 over x. So my dy now dx is just going to be equal to 4 power w is just ln 4x times ln 4 times 1 over x. So my answer, my final answer now, dy dx is just going to be equal to 4 power ln 4x times ln 4 over x. So when y now is equal to 4 power ln 4x, dy dx is just going to be equal to 4 power ln 4x times ln 4 over x. So this is the derivative of this. So this is all about derivative of exponential functions. Let me just say, see you in the next tutorial.